Hello. I'm Sardos, and today, another day of AOC 2024 is ahead of us. This time, 7. Today's topic, AWS log analysis. If you don't know what AOC is, refer to my first video where I explain it briefly, or check out the first link in the description. To join us in our Waiting for Christmas, check out the second link, and yeah, that's right about it. Let's read the story. As Sogma's approach so did the need to provide those without with something to read. Careful wearers tried, they made it their mission, a gift for all wearers, a Sogma's tradition. Although they had some, they still needed more. To pick up some books, they'd head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, the shopping was done. When I asked for their card, they were handed them one. "I'm sorry," he said, as the shop clerk reclined. "I can't sell these books, as your card has declined." The wearer put them back as they walked in confusion. How could this be? An attack? An intrusion? And when they logged on, the wearer got a scare to find donations they just weren't there. Careful Wearers infrastructure runs in the cloud, so they choose AWS as their cloud service provider, CSP. Instead of their workloads running on physical machines on premises, they run on virtualized instances in the cloud. These instances are in AWS called EC2, Amazon Elastic Compute Cloud. A few members of the Wareville SOC aren't used to log analysis on the cloud, and with a change of environment comes a change of tools and services needed to perform their duties. Their duties this time are to help careful wearers figure out what has happened to their charities found. To do so, they will need to learn about AWS service called CloudWatch. Now, what's CloudWatch? It's a monitoring and observability platform that gives us a greater insight into our AWS environment by monitoring applications at multiple levels. Alright, CloudWatch provides functionalities such as the monitoring of system and application metrics and the configuration of alarms on those metrics for the purposes of today's investigation. Though we want to focus specifically on the CloudWatch logs. Running an application in the cloud environment can mean leveraging lots of different services, running the application, running functions triggered by the application, running the application's backend, etc. This translates to logs being generated from lots of different sources. CloudWatch logs make it easy for users to access, monitor, and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. A key feature of CloudWatch that will help the Wareville SOC squad and us make sense of what happened in their environment is the ability to query application logs using filter patterns. Filter patterns. Here are some CloudWatch terms you should know before going further. Log events is a single log entry, recording an event. Log streams, collection of events from a single source. Log groups, collection of log streams. Right, so we have like events, streams, groups. To be honest, I've never had anything to do with AWS, furthermore with AWS security, so it's really interesting. CloudWatch can track infrastructure and application performance, but what if you wanted to monitor actions in your AWS environment? These would be tracked using our service, called AWS CloudTrail. Actions can be those taken by user role, granted to a user giving them certain permissions, or an AWS service, and are recorded as events in AWS CloudTrail. Essentially, any action the user takes via management console or CLI or service will be captured and stored. Some features of CloudTrail include always on, JSON formatted, event history, so we can see event history, even histories record actions have taken place in the last 90 days. They're queryable, alright. Trails, the above mentioned event history can be thought of as a default trail included out of the box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store it beyond 90-day event history retention period. Observable. CloudTrail can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch OS, so we can just integrate both. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, like S3, simple storage service used for storage, IAM, identity and access management service, It can be used to secure access to your AWS environment with the creation of identities and assigning of permissions to those identities who have actions taken within their service record. These recorded events can be very helpful when performing an investigation. Now it's similar to JQ. Earlier, it was mentioned that the CloudTrail logs were JSON formatted. When ingested in large volumes, this machine-readable format can be tricky to extract meaning from, especially in context of log analysis. The need then arises for something to help us transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is, and similar to command line, tools like sed, avk, or grep, JQ is a lightweight and flexible command line processor that can be used on JSON. Let's take a look at how we use JQ to transform and filter JSON data. The wheres being wheres, they store shopping lists from trip to bookstore in JSON format. Let's take a look at that. Whereas Woolery, blah blah blah. Alright, just JSON. JQ takes two inputs, the filter you want to use, followed by the input file. We start our JQ folder with a dot which just tells JQ we're accessing the current input. From there, we want to access the array of values stored in JSON with the square brackets, making our filter this. For example, let's run the following command. It will result in this output. We want to just format as the JSON. Nice. Once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we can run this JQ command and we can grab all the book titles. Alright. Now that we have refreshed our knowledge of AWS CloudTrail, or just learned what it is, and alongside MaxKD, let's investigate this peculiar case of care4where's reference. This possible where for care4where charity gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. Details include an account number to receive donations. We received many donations the first day after sending out the link, but there were none from the second day on. I talked to multiple people who claimed to have donated a respectable sum. One showed his transaction and I noticed the account number was wrong. I checked the link. It was still the same. I opened the link, and the digital flyer was the same except for the account number. MaxKD recalls putting the digital flyer Whereville Bank account QR in Amazon S3 bucket named Whereville care4wheres. Let's assess MaxKD and start finding out more about this link. For that, let's review the first information we currently have to start the investigation. First day, the link was sent. Second day, there were no more donations. Donator has shown a proof of transaction made 3 days after receiving the link, and the account was wrong. MaxKD put the flyer on Whereville Bank account QR PNG and our backend Whereville care4wheres. The link has not been altered. Alright. We have information. Let's start with VM. This task. Machine can take up to, oh yeah, parsing error, amazing. Let's refresh the page. And has a split screen available. Yeah, as I said, I've never really used AWS, neither have I been into its security. I know TryHackMe has a paid path purely for AWS security, so yeah, I hope one day I can check it out. Many people did this. Yeah. Oh no, speaking CloudTrail. This is the first day. Yeah. We did it. Alright, we read all this, and now we can try to start the machine. It's loading. Oh, it's higher love having. This is a CPU, right? Yeah, this must be a CPU. Alright, machine is loading. Is there anything else interesting we can find? Let's maybe start with reading. Ooh. I guess I've lost. Alright, here it is. I got this. It was back. Let's examine the CloudTrail logs related to the Whereville care4where S3 bucket. For a quick example, a typical S3 log entry looks like this. You have event version, user identity, type, principal, account ID, access key, username. Alright, it's just some IDs, data, and stuff. Might be overwhelming to see the sheer amount of information in one event, but there are some elements we can focus on for our investigation. User identity, so details of user account acted on an object. Event time, when it occurred. Event type, what it happened. Event source, from what services it came. Event name, what action occurred. What's the IP address, user agent, and some request parameters. By using the guide above, we can read the example log entry as follows. The EM user value collector lists all objects of the S3 bucket named AOC CloudTrail variable. IP address comes from this. It was made using the AWS SDK tool for Go. Is it here? Let's check it. Have variable collector using AWS SDK Go, listing all the objects. Then he sent an authentication header, and it's just a header, yeah. And then the API call response is AOC CloudTrail. Now that we know where to look, let's use our GQ filter to log for events related to variable bank account QR.png S3 object. The goal is to use the same elements to filter the log file using GQ and format the results into a table to make it more readable. According to MaxK, the logs are stored in the home/variable logs. Alright, yeah, this little tilde means home. Start terminal on desktop and enter the commands below. Let's try it. Let's choose variable logs and list all. F CloudTrail and RDS. With the commands above, we initially change our current directory to the directory MaxK mentioned via the cd command. And we list all the directories using ls. Yeah, list all just lists you additionally all the hidden contents, so going like up directory, and also permissions and details. Now let's start investigating the CloudTrail logs by executing the command below. Alright, let's type jq-r.records and yeah, select .event source equals s3.amazon aws.com and .request parameters .bucket name equals variable careful words. Close this, and yeah, oh yeah, forgot. You choose the file. Cloud trail log.json. Not cloud. Let's make it a full screen. CloudTrail. We have all the things. First, let's maybe read this. It's the R tells to put results in raw format, so JSON. And filter is section close single quotes. The last part commands input file. Right, then we have to parse the events in records container and records fields top element JSON formatted CloudTrail log. Alright, so we parse just this element and we search for event source based on event source and event request parameters bucket name. Do we have it here? Maybe somewhere. Request parameters bucket name. Yes, it's here. And also event source S3 Amazon. As you can see in the command output, we were able to trim down the results since all the entries are from S3. However, it's still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Yeah, execute the following command. I need to take some breath or something. Just append here .event time .event name .user identity .user name / not applicable dot request parameters dot get name. Also give slash slash not applicable. Dot request parameters dot key slash slash not yeah, and slash a is applicable. Dot source IP address slash slash not applicable. I guess I just need to add the have before the event. Yeah, everything is there. We can now click enter, and all the logs which were meant to be returned are there. We have another pipe. That's our previous filter. So there is the pipe filter uses the previous command's output and formats it to only include the defined keys such as event time, event name, and user identity dot username. Defined keys are closed with square brackets to process and create an array with specified fields from each record. Alright, so we just create an array. Note that the string slash slash not applicable is included purely for formatting reasons. This means that if the defined key does not have value, it will display not applicable. Alright. As you can see in the results, we should focus on notable items, but our initial goal is to render the output in the table to make it easy to digest. Let's upgrade our command with additional parameters. We also need to add to the back column -t. And I guess it gave me the same thing, just oh yeah, there were some more stuff to here. All right, I must have missed it. GQ-R. All right, first we go home and we go to our before the records. We just need to open the brackets and add event time, close, event name, user name, bucket name, key, and source IP. Close the bracket and add this. Then we go to the we go then to the end, and after this we append another pipe at TSV, and then after all we can just add this column -t. Let's add something from there, so it will be -t -s $/tab. GQ compiler. Yeah, amazing. I must have not closed something or just mistyped something. Yeah, I must have been. Oh yeah, I did not close the. This one should be closed here, and I did not do it. Alright, we have the key, we have the event time. New command prepends a column header row which is defined using square brackets since it is an array that corresponds to the selected fields. That the comma is used before the select folder to combine with those of the select folder results we previously used. So yeah, this is like for the table headers. Then we use comma to combine with the results and set each array element to output processed after the filters as line of tab separated values. And then we beautify the result by processing all tabs and aligning the column. Note, our crafted command lets us summarize S3 activities from a Cloud Trail log. Now that we have crafted JQ query that provides a well-refined output, let's look at the results and observe the events. Based on the columns, we can answer the following questions. How many log entries were related to queryville buckets? I guess we're just like one to... Can I just, I don't know, can I make this smaller? Probably I can one way or another. Full, that's alright. Never mind. We're gonna figure it out later. How many entries are related to where we'll care for where's bucket? Which user initiated most of these log entries? Which action did the user perform based on the event name field? List object, put object. Alright. Were there any specific files edited? What timestamp the log entries? And what was the source IP? They'll come from the same one. Look at the results. 5 log events seem related to where we'll care for where's bucket, and almost all are related to the user glitch. Aside from listing the objects inside the bucket, the most notable details is the user glitch uploaded this where'll bank account QR.png on November 28th. Yep, that's it. Put object where'll. This seems to coincide with the information we received about no donations being made after 2 days. The link was sent out. MaxKD is sure there was no user glitch in this system before. There is no one in the city hall in that name either. The only person that MaxKD knows with that name is a hacker who keeps it to himself. MaxKD suggests that we look into this anomalous user. MaxKD wanted to know what this anomalous user had been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. Alright, we have this command. I'm going to retype it. I think we should understand everything now. We can just remember, when you copy from the browser, it's Ctrl-C and not Ctrl-Shift-C. Yep. We can just maybe... Wait, I didn't choose JQ? Hold on, that must be some copy and paste. Now I should have it in clipboard, so I can just... Yep, I have it. Yep, it's event time. Let's maybe just... Yep, now we can run it. This result shows us the user glitch mostly targeted the S3 bucket. The most notable is the console login entry. Can we find it here? Here it is, console login. Which tells us the account was used to access the AWS management console using a browser. We still need information about which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. In the end, after source IP address place not applicable, we can just add .user agent. Also replace nothing with not applicable. And yeah, that's really about it. We got something more. There are 2 user agent values included in all log entries related to glitch user. We have S3 console, which is here. User agent string for the internal console used in AWS. And the second one is Mozilla, Macintosh, Intel. Anomalous account uses Google Chrome browser within the Mac. Here's a Mozilla, and here was Mozilla as well. It's like Mozilla, Macintosh, Intel, Mac, Apple WebKit, Chrome. Yeah, it says Chrome here. An experienced attacker can forward these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We'll pair the current information for now. Let's gather more info to connect the dots. The next interesting event to look for is who created the anomalous user account. We'll filter for all the EM related events, and this can be done by using the select filter. We can also add their event source. Alright. We'll probably be requesting everything. Identity, select, maybe not. That won't be user identity, username glitch, but now we're gonna select dot event source equals em.amazon.aws.conf. Create to a user maxkitty. All the stuff here is maxkitty. This was before, and based on the results, there are many list policies. By ignoring these events, it's seen that most significant IAM activity is about the user maxkitty, invoking the create user cache and consequently invoking attach user policy. The source IP where the request were made is 53.94.201.69. The same IP the anomalous user glitch used. Let's have a more detailed look at the relevant create user by executing the command below. Just copy it here, and paste it here. We're selecting records, everything from there. We're event source IAM AWS, and event name is create user. Based on the result, parameters can be seen that it was user maxkitty who created the anomalous account. Can we? Yeah, we created the user glitch. Now we need to know what permissions the anomalous user has. It can be devastating if it has access to our whole environment. We need to filter for attach user policy event to uncover the permissions set for a newly created user. This event applies to access policies to all users, defining the extent of access to the account. Let's filter for the specific event by executing the command below. Alright. Event name, event source, and let's instead of create user, we'll be using attach user policy. maxkitty is baffled by these results. She knows that she did not create the anomalous user and did not assign the privileged access. She also doesn't recognize the IP address involved in the events and does not use a macOS. She only used a Windows machine. All this information is different to the typical IP address and the machine used by maxkitty. So she wants to prove her innocence and asks to continue investigation. Alright, so we can... so just gave glitch admin access. Logs online with a poetic name. maxkitty suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below to continue the investigation. We're selecting event name for all the stuff for all the IP address. Alright. Copy. Yes, Control Shifts. I click Control Shift C and Control C. I can just paste here. Based on the commands, we see 3 user accounts: maxkitty, glitch, and malware, were accessed from the IP address. The next step is to check each user and see if they always work from that IP. Console login, describe, yes, malware, glitch, and then maxkitty. So this person pretty much compromised plenty of users. Let's focus on each user. Let's see if they work. Enter the command and place the placeholder with the username. While gathering the information for each user, we can focus our investigation on the following questions. What IP does each user typically use to log into AWS? Which OS and browser does each user actually use? There are any similarities to explicit differences between the IP addresses and the operating systems used. Based on the results, we have proven that MaxKitty used a different IP address before the unusual authentication was discovered. Moreover, all evidence seems to point towards another user after correlating the IP address and using user agent used by each user. Who do you think it could be? MaxKitty has processed all the information results and summarized them below. The incident starts with an anonymous user from the account called MaxKitty at this and this. Shortly after the login, an anonymous user glitch was created, then glitch was assigned the admin privilege. Glitch uploaded where the bank your PNG and used to log into the MaxKitty were the same. Or IP address and user agent are the same, and user agent string and source IP of the current logins by the account MaxKitty were different. Right. MaxKitty suggested gathering stronger proof that person was behind the incident. Luckily, Werville Bank cooperated with us and provided their database logs from their Amazon relational database service. They also mentioned that these are captured through their CloudWatch, which differs from the CloudTrail logs as they are not stored in JSON format. For now, let's look at the bank transactions stored in the Werville logs RDS logs. RDS, alright, let's maybe... Since the log entries are different from what previously investigated, MaxKitty provided some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. Grep is the use command utility for searching strings within... For the command above, MaxKitty explained that all insert queries from RDS log pertain to who received the donation. Given this, we can see the output of the two recipients of the donations were made within November 28, 2024. As shown below, the careful funds received the donation until changed into a different account at a specific time. The log also reveals who created the donations afterwards, given the account's own name. With all these findings, MaxKitty confirmed the assumption made during the investigation of the S3 packet, since the sudden change in the bank details was reflected in the database logs. The timeline for events collected by MaxKitty explains the connection of actions conducted by the culprit. Last donation was here. Alright. What is the other activity made by user glitch aside from list object action? We had this. Here is the MaxKitty. Here we have discovered what MaxKitty is doing. And yes, let's maybe go back up here and we can read events done by glitch. Let's copy this, scroll back and paste it. Oh yeah, I forgot. I have to change it here and replace placeholder with glitch. Right, let's maybe kill this and paste again. What is the other activity aside from list object action? Let me just because we have here list object, put objects, maybe. Yes, source IP related to, it was up there. It's also here, it's 53, 94, 208, 69. Based on the event source field, what AWS service generates console login event? We have it here. It's sign-in.amazonaws.com. When did the anomalous user trigger the console login event? Let's copy everything. Copy this as well and paste it here. What was the name of the user that was created by MaxKitty user? It was glitch. Let's clear it, and maybe we can just go back up there and replace username glitch with username MaxKitty. MaxKitty. She gave, yeah, I mean, alright, we will not find it here. We're gonna find it up there. It's list policies. Here is administrator access. See, someone, so probably MaxKitty. Yeah, I'm just gonna administrator access. What IP does Mayor Malware actually use? Used to log into AWS. Let's maybe now first copy this IP address, which is the IP of MaxKitty. Copy and paste. Yes, this one is hers. Which is Mayor Malware typically used. Alright, so we'll have to do the same thing again, but right now change username from MaxKitty to Mayor Malware. Yes. Oh god, how I love myself. Let's go home. And we can delete all this stuff and just put there Mayor Malware. Mayor Malware uses source IP is here. It's 59. Is it the same one? The glitch used, because that's what it looks like. Let's try it. Yep, that's the same one. And what's the bank account number owned by Mayor Malware? So we will have to use grep, have grep insert rds dot log. All right. Insert there to what's the bank account number? Here is Mayor Malware, and it's this one. Let's copy this, Control Shift C, of course, and Control C, Control Paste. And yeah, that's really about it. It was a fairly interesting room. I mean, as I told you, I never learned about AWS anything, and this gave some cool intro. So yeah, that's really about it. I hope you enjoyed staying here with me and solving this task. See you tomorrow with another day of waiting for Christmas. Cheers.